Okay, hello everyone. Last class we have been discussed or proved the laws of reflections and refractions at plane interface by using format principle. In this class we are going to discuss matrix formulation of geometrical optics. Okay, so let us start. So to understand about matrix formulation of geometrical optics, first consider two polynomial equations. That is your x1 equal to ay1 plus by2 and x2 equal to cy1 plus dy2. Here a, b, c, d are constants. The above two equations can be written in matrix form as x1 x2 is equal to this constant a, b, c, d written as 2 cross 2 matrix, and here the variables are written in the form of 2 cross 1 matrix. Okay, 2 rows and 1 column, here 2 rows and 2 columns, into y1 y2 another matrix. So these two polynomials or equations are written in the matrix form as like this. These things already we know in our intermediate classes. Now consider another two equations, that is your y1 equal to ez1 plus fz2, y2 equal to gz1 plus hz2. Here E, F, G, H are constants. Now if I am going to write these two equations in matrix form, then we can write in this way: y1 y2, that is your 2 cross 1 matrix, is equal to E, F, G, H, which is your 2 cross 2 matrix. This is your 2 cross 2 matrix into z1 z2 another matrix, that is your 2 cross 1 matrix. Now here I am going to substitute instead of, see, here if I'm going to consider this one x1 x2 matrix, which is equal to a, b, c, d 2 cross 2 matrix into y1 y2 another 2 cross 1 matrix. So instead of y1 y2, here I am going to substitute, then I can write x1 x2 matrix is equal to a, b, c, d 2 cross 2 matrix. Okay, instead of y1 y2, we can write this one E, F, G, H another 2 cross 2 matrix into z1 z2. So here we can get the information regarding x1 x2 if we know this value. Okay, if I operate this matrix, see, if I'm going to multiply these two matrices, then also we can get 2 cross 2 matrices. Here I discussed. For that, for simplicity, here I considered x1 x2 matrix as your x and z1 z2 matrix is your z, and b is another matrix. If I'm going to consider these multiplication of these two matrices, I can get this one. This is itself a 2 cross 2 matrix, right? Now here I can get x or this matrix by applying b upon z1. That means here b matrix, which is a 2 cross 2 matrix, act as like a operator which is operated on z matrix, and we can get the x matrix. Okay, so like this, suppose we have information about z matrix and we are going to operate this 2 cross 2 b matrix, we can get the information regarding x matrix. From the above matrix formulation, we can write the polynomial equations as here x1 will be this one, ae plus bg into z1 plus af plus bh into z2. Same thing I have been written over here. And x2, the value x2 will be this one. Okay, so simply if we are going to understand whatever we discussed now, if we have information regarding one variable and this operator matrix, we know we can operate this matrix on these variables and we can get another two variables, right? Here these matrices are called transform matrices or ray matrices in your geometrical optics. Now one can think, uh, or one question will be induced in our mind, how these matrix formulations will be used in geometrical optics. That we are going to discuss in our next class. But if we are going to consider geometrical optics or ray optics in general, if we are going to define, then it will be defined as, this is the model in optics. Geometrical optics or ray optics is nothing but a model through which translation, reflection and refraction of light rays can be explained mathematically, which is nothing but your geometrical optics. So here, translation of light ray in a medium means light ray translate from one point to another point like this. Okay, reflection of light ray from a surface like this, refraction of light ray at the interface of two mediums like this. So these physics, translation, reflection and refraction of light ray can be represented by matrix formulation. How it is, that we are going to discuss in our next class. Application of matrix formulation in geometrical optics. First we are going to consider the translational matrix. That means if the light ray will translate from one point to another point, then how it will be represented by the matrix formulation. Then we are going to discuss the matrix formulation of reflection and then refraction. Okay, so thank you so much for watching this video. Thank you.